Welcome, everyone, to CHRS. Thank you so much for being here. While you are here, please take a look around and visit us on Saturdays to see the California Historical Radio Society in action. Also, please visit our website at chrsradio.org to find out about more events like this one. Good evening. And thank you for joining us for today's presentation on the fascinating history of Maritime Coastal Radio Station, KPH. The history of KPH is deeply intertwined with the development of radio communications itself, starting in 1905 as PH at the Palace Hotel in San Francisco. As radio technology advanced, so did KPH, until technology eventually rendered it obsolete. But the story doesn't end there, and today we are fortunate enough to have Bill Ruck, a member of the Maritime Radio Historical Society, here to take us through this incredible journey. Bill is a San Franciscan with a lifelong passion for radio. His career in broadcasting, starting with his service in the U.S. Navy and spanning work with stations like KFOG and KUSF, reflects his deep knowledge and dedication to radio communications. For nearly 20 years, Bill has been an active member of the team that keeps KPH alive and on the air, preserving its legacy for future generations. Please join me in welcoming Bill Ruck.
Okay. I'm going to try not to pour this into the radio.
So you can use the...
Yeah. Right. Thank you very much. As Michelle said, I'm a member of the Maritime Radio Historical Society. Actually, I'm a member of two historical radio societies, the CHRS and the MRHS. So as you might expect, I have a little bit of interest in the history of radio. And one of the things that even though I'm involved in state-of-the-art stuff today, tomorrow I will hear Morse code on 600 meters, going back 100 years in technology. So I kind of do both. So if I ever say something, you go, huh? Wave your hand, we'll hand a mic to you, and ask a question. I have slides. They're more or less to keep me on track, but I can get digressed. And actually, if I go off track, we'll be here about 2 or 3 o'clock in the morning, and I'll still be talking. So don't worry about that. So one of the things that the Maritime Radio Historical Society is more than just some wonderful artifacts like old transmitters and receivers and things. The mission of the Maritime Radio Historical Society is to preserve the history, culture, craft, and lore of maritime radio. Besides the transmitters and receivers and all the hardware, one of the things we honor are the men and women that were radio officers in the merchant marine. Because if you were the radio officer on a merchant ship, you had to know Morse code. You had to know all the policies and procedures to pass messages, had to be able to fix everything on board the ship, because everybody was dependent on you to communicate with the ship, from the ship to wherever it needed to be. So it was more than just a job, it was a craft. And we want to preserve that because today it's not a craft anymore. It's like everything else has been turned into email via satellite. So one of the things that people today don't realize is that a ship would sail from a port in the 19th century and 3, 4, 5 weeks later would show up, or it wouldn't. Ships were routinely lost at sea, all hands, they just never showed up. Nobody knew what happened, nobody knew anything, they just didn't show up. So that's one of the reasons why the maritime industry was the first to really embrace radio communications, where a lot of other people say, oh, that's nice, but the maritime industry really was the first to push forward the whole technology of radio communications. And so I found this, old prose is so much better than what we see today. The sea has always meant peril and mystery to mankind. Its trackless waters carried the commerce of the world, but for ages its darkness was dreaded. Then with its mastery challenged at the fluttering of the curtain, which revealed a new application of the forces of nature, the greater fear took wings and the dread of the sea abated. And that's because a ship can now call for help, all right? But the reality in the maritime industry is it was not the SOS, it was just basic routine business messages. probably 1 in 10,000 messages were an SOS. Most of the rest are just routine stuff. Ship owners would make the captain report daily what their location was. Or a ship would be approaching a port, it would call ahead and say, hey, I'm going to be in port on Tuesday. What berth do I go to? Or I'm going to need a pilot, or I'm going to need a tug or something else. More importantly, a ship could call and say, I'm going to be in port on Tuesday. I need 100 pounds of potatoes, 50 pounds of coffee, and a bunch of other provisions. Or the ship's engineer could say, hey, I need a bunch of 1 inch by 4 inch long bolts. So all of that now became just routine business that was what kept the maritime industry working more efficiently. So that's really the important part of the story here. The technology is what I love, and I've been doing it for years. But it's the whole picture of the communications that is, I think, the whole story, and that's what I'm going to try to give you a little bit more than just that. I'm starting off with Senatore Guglielmo Marconi because he was the founder of radio as far as I'm concerned. He also played a part in the station KPH. But what separates Marconi from everybody else in the late 19th century was Marconi was the first person to say, I can make money sending messages without wires. Those are two important distinctions, because in 1880, a lot of college professors were trying to understand Maxwell's equations from 1860, like Heinrich Hertz and a few others, but they were not interested in doing anything other than experimenting and learning because they were college professors. Marconi was the first person to see it as a business, a way of making money. So today, when you send a text message from your iThing, you're proving he had the right idea 140 years ago. Secondly is without wires. State-of-the-art communications in 1880 was wireline telegraphy. Worked great across the United States, worked just fine across Europe, worked very badly across the Atlantic Ocean, and if you're moving, didn't work at all. So the difference between wireline telegraphy and wireless telegraphy was you didn't need those wires. And that was, so those two distinctions are what make Marconi important to the story of all of radio communications. So do we have any Marconi fans out here? Okay, I have a couple Marconi fans, good. Well, one of my questions for you is, who was Marconi's angel investor? In other words, who invested money in getting the Marconi company started? Yes, it was his mother, okay. And that is another part of the story. It's a very important part, actually. Marconi was Italian. His father was an Italian landowner and gentleman farmer. His mother, though, was not Italian. She was Irish, from the Jameson whiskey family. So it is Jameson whiskey that founded all of radio. So not while you're driving tonight, when you go home, pour yourself a couple fingers of Jameson and toast them for starting the entire industry. But more importantly, beside the money, more importantly, the family said, okay, this is a good idea. We're going to get behind you, but we will manage your company. And so Marconi's first manager was one of his cousins at Jameson, and he did two important things. First, he kept him from spending him into nothing. I'm sure there was some conflict there, because he would say, oh, Guglielmo, we're not going to do that this month. We're going to put money in the bank for 3 months, then I'll let you do that. So controlling the purse is important, because most experimenters, people, have no clue how to run a business, and they run it into the ground. But most importantly, though, his cousin said, you will patent everything you do. And that's why Marconi had the controlling patents for wireless at the turn of the century. It's what's known as the 4/7 patent, British patent 7777. That it was the controlling patent for wireless at the beginning of the 20th century. So those are two. Anyway, that's why Marconi did play a part in the story here, but that's why he's important to the entire story. He did not invent radio. He assembled a system. He used a lot of other people's ideas and technology and perfected them and made them work together, but he was mostly interested in the system of sending messages and collecting money doing that. So we're going to skip over Marconi across the Atlantic and a whole bunch of other stories, but I'm going to start now with station PH. Started at the Palace Hotel in San Francisco in 1905 by the American DeForest Wireless Company. And in fact, I just wrote a testy letter to somebody about Lee DeForest. He was a guy that was more of a promoter and a speculator and a scammer than he was an inventor. And it just turns out most of what he claimed to have invented, he stole other people's ideas. And those of you that are members of the American Wireless Association, Antique Wireless Association, the last two issues of the journal had a very detailed article about how Marconi stole Fleming's patents and patented himself and ended up being sued and lost the suit. So he did not invent the vacuum tube. He stole it from Fleming.
The Audion or the vacuum?
The Audion.
Okay.
That was and there was a trial in 1916, and
He couldn't explain how it worked.
he couldn't explain how it worked. And anyway, AWI members out there? Okay, that's a very interesting thing, and it proved what I've always suspected, was that he was a scammer. And as far as I'm concerned, DeForest only avoided jail because he was lucky. He was involved in too many scams about doing things. I'd be pretty sure that the receiver at PH was the DeForest spade detector, which was a copy of Fessenden's point detector. It's a wire in a cup of acid, and which he ended up losing the patent suit and having to find another form of detector. This is the only picture we can find of the operating position at Station PH in 1905. And it was before rotary spark. It's probably this little buzzer spark like you have a demonstration back there, and probably used the DeForest spade detector for receiving. So they were just getting started. There were a few ships with wireless equipment in 1905. Then April 1906, we had a little problem in San Francisco, and the station and the hotel burned to the ground. It's partly why we don't have any records of that, because it all burned to the ground. But these guys were pioneers. They didn't give up. They reformed another company, and they built a second radio station on Green Street on Russian Hill in San Francisco, and it was then called the United Wireless Telegraph Company. So here's a shot of PH. You can see the, I can't do it from here. Anyway, you can see the mast at the top of the hill there. This is another shot of the station here, a little house for the transmitter and receivers, and a wooden mast that held up a whole bunch of wire, and that was the antenna for Station PH. Well, consistent with San Francisco history of today, they had NIMBYs in 1907. The neighbors complained about interference from the transmitter. Well, not really interference to the TV sets and cell phones, but they didn't like the fact that the lights would flicker when they keyed the transmitter, and they really didn't like the buzz of the spark transmitter at 2 o'clock in the morning. So the neighbors made a big stink, and they forced the station to move again. They moved to a site called Hillcrest, and this is a shot much later of the transmitter shack and part of the antenna system at Hillcrest. We would now call that Daly City, but Daly City didn't exist in 1916. Actually in 1908 when they moved there. One of the interesting problems with the Hillcrest site was just up the street, sort of, across from the Great Highway, was another station, and because the receivers in those days were not very selective, whenever that station was transmitting, it would blanket the receivers at Hillcrest, and they had a continuing battle between them over operating the site at Hillcrest. So Hillcrest had an antenna 250 feet high, 500 feet long, with 25-foot long spreaders. Typical antenna of that time was a bunch of wire and parallel wire. They made it broad, even though it was short. The wireless shack was directly below the center of the antenna, and the transmitter was a 5-kilowatt open core rotary spark gap, a big step up from what they had at the Palace Hotel. This is a shot showing the Hillcrest in the middle with the two wood towers and the wire strung between there. This is the operating desk at Hillcrest, a little bit later because it's a vacuum tube receiver. If you'll notice, hanging down from the table, kind of in the middle of the picture there is the handle of a revolver. It was not there to protect them because there was no money there, it couldn't be robbed. That was there for skunk control. The skunks like to take over the building, and so in order to keep the skunks at bay, they were armed with a little, probably a .38 or something. And on the side, you can see the controls for the transmitter. This is the back of the transmitter, a little motor and a rotary spark gap, very similar to the one that you have back over there, and some coils, and that was the Hillcrest transmitter. This is today Hillcrest, and you can see all the houses there. And then there's a little bit of foundations of what used to be support the house, the transmitter building at Hillcrest. So this is how Marconi got involved. The Marconi Wireless Telegraph Company of America sued the United Wireless Telegraph Company for patent infringement because they were clearly infringing Marconi's patents. Remember, patent everything? Well, that's why they were able to do that. They lost in 1912. The Marconi Company took over a station, probably still then PH. The K's came later. But at the same time, the Marconi Company was making money in buckets, sending messages across the Atlantic because they could do it a lot less expensively and a lot better than the undersea cable between the North America and Europe. And so they said, hey, let's do the same thing across the Pacific. So the Marconi engineers selected Point Reyes area for the United States station to serve the Pacific Ocean, basically here going west into the Far East. They chose the mesa on the very west edge of Bolinas, selected for the transmitter site, and its sign was BL. The reason for that was they could get utility power in Bolinas, and so they paid the local electrical monopoly to bring power into Bolinas. That's why the town of Bolinas had electricity before anybody else in West Marin, because the Marconi Company paid to have power brought out to Bolinas. And they selected Marshall on Tomales Bay was the receiver site. Marshall had a bunch of different names and just a couple of fishing shacks, but that's where they bought property and built the receive site. The Marconi Company had already learned that you can't run a high-power transmitter and receiver at the same time. So the receiver was separated from the transmitters, and the Bolinas transmitter were remote controlled by the operators in Marshall. So actually, there was one transmitter in Bolinas at that time. Construction started in 1913, and the facility opened on September 14th, 1914, with a call KET. And it was this one transmitter, a huge rotary spark transmitter that they used to talk to the Far East. Originally, they could go from Bolinas to Hawaii, and then Hawaii to the rest of the Far East. But as receivers improved, they could talk from Bolinas directly to the Far East, one hop. The Bolinas transmitters, they had two, a main and a backup, 300 kilowatt rotary spark transmitters operating on a frequency of 6,700 meters, or a frequency of 44.7 kilocycles per second. By the way, as a historical society, I'm not allowed to use that modern term. We use cycles per second as God intended. The transmit antenna was 2,000 feet long and 600 feet wide. Again, a short but very wide antenna, supported 300 feet in the air by 3 rows of masts. Now, this is one of the conundrums I regularly say. Didn't they know whenever I'm reading about these things? And the reality was, at that time, they didn't understand antennas. They didn't understand resonance, because a resonant quarter wave antenna at 6,700 meters would be 1/4 the length, or 1 kilometer and a half long. So the actual antenna was like 1/10 of a wavelength long. Didn't work very well, but that's what they did. When you look at transmitters in the beginning of the 20th century, most of the antennas were not designed by today's standards. And in many cases, the amount of wire they put up was determined by their budget. They just kept putting up wire until they ran out of money, and that was called an antenna. And they tended to be wide rather than resonant length. So the Marshall receiving antenna was nearly a mile in length, so that was long enough to be a good antenna, supported by 7 of those 330-foot high masts, and the KPH Maritime traffic stayed at Hillcrest. So that's Marshall. It's still there, although they've planted trees. So the middle of there was the hotel where all the operators lived, and in the little house with smoke coming out of it, that was the power plant. There's no utility power in Marshall, and the little house on the left was the operating position. So you can see the masts and the antennas going to the east from Marshall, and the tower in front here was the balancing antenna. What they would do is they would mess with the amplitude and phase with the balancing antenna to the main antenna to null out the Bolinas transmitter. So they could receive If when full duplex, they could receive and transmit on the same frequency, but they could receive and transmit at the same time. Another shot of the operating position, the balancing antenna at Marshall. Here's a close-up of the hotel and the powerhouse. The powerhouse now is the conference center at Marconi Conference Center. There was no road into Marshall at that time. To get there, you either took a boat out the bay, came around Tomales and came in, or you took a small train that went from Mill Valley over the hills into Marshall. In World War I, the American government shut down all of radio stations. For a lot of reasons, a little bit of paranoia, but mostly because they found out that the German Telefunken station on the East Coast was sending coded messages of ships sailing from New York Harbor to submarines. The government thought that was a bad idea, so they pulled the plug on everybody. The Navy took over the two West Coast stations, KET and KPH, and took over the Marconi East Coast stations as well and operated them during the war. When the war was over, Marconi wanted to go back into business because they wanted to make money. I mean, that's what they want to do, sending telegrams across the Atlantic and the Pacific Oceans and ships and everything else. The government kind of stalled and said, we don't want foreigners owning our radio stations. And at the same time, there was an internal battle within the United States between the Navy and the federal government over who would control radio. The Navy had found out how useful it was to have radio during the war, and they wanted all of it. And the government kind of went, no. We'd see other reasons for that. It took over a year, and finally it got to the president and said, no, the Navy will get frequencies, but we will control the spectrum. And to this day, that's what is the FCC. It's an agent of the federal government that controls the spectrum. So they went back to the Marconi companies and said, okay, you're never going to get a license from us because you're not an American company. You're owned by the Marconi company in Great Britain. You're a foreigner, we don't want foreigners. So they forced the sale of the Marconi Wireless Telegraph Company to the newly formed Radio Corporation of America. And besides the American, the title, actually it was owned by U.S. corporations, so it was a U.S.-owned company, and that's why RCA took over that. And RCA also ended up becoming a patent pool for receivers and a bunch of other things, but the main reason why RCA was formed was to take over the assets of the Marconi Wireless Telegraph Company. RCA took over on the West Coast, Bolinas Marshall, Kahuku, Cocoa Head, Hawaii, and New Brunswick, New Jersey on the East Coast on March 27th, 1920. The Navy kept Hillcrest. They liked it, so they didn't want to give it up. And, you can argue with the Navy. So KPH moved from Hillcrest to Marshall in April 1920. Transmitter first was a 1.5 kilowatt quench gap at Marshall, which was a problem because now you're transmitting and receiving in the same place. So ultimately, KPH transmitter was upgraded to a 7.5 kilowatt transmitter in Bolinas. So again, we have a remote control transmitter in Bolinas, receivers in Marshall. This is the operators in Marshall with a VLF and a medium frequency receivers. But there's an important artifact you see on the left there is a telegraph sounder, okay? Now think about that. The only way you could get a text message in and out of Marshall in 1925 was wireline telegraphy. So the operators there would do both radio as well as landline Morse. And that's tricky because radio Morse was Continental Morse, which became International Morse code. The wireline was American Morse code. They're not the same. It's like Italian and Spanish. They're close, but they're not the same. So these guys were bilingual in Morse code. And since I've been rhythmically challenged my entire life, I really respect the fact that these guys do both. And this is an example of how important radio became. In October 1922, a fire was reported in the city of Honolulu with 261 people on board more than 600 miles offshore. KPH coordinated the rescue with the West Farallon, Thomas, and Enterprise ships. All on board was saved by the time for the city of Honolulu sank. So that is an example of why wireless or radio became important to the maritime industry. This again, they don't write headlines like this anymore. A wireless net cast over the Pacific Ocean Thursday swept nearly 300 souls to safety and scored another victory of the air over the sea. You also can see why I was never an announcer in radio. But anyway, KPH Arthur Isbell, who was the manager, claimed that KPH received the SOS hours before any ship in the Pacific, and they were the only station powerful enough to communicate with all the vessels necessary to effect the rescue. So that is an example of why radio is important to the maritime industry. Here's another shot a little bit later of the KPH operators at Marshall. Still, there's a telegraph sounder in the middle because they had to be able to do both kinds of Morse code. So now we end up another generation of technology better. So in 1920, they were operating very low frequency at very high power, but all of a sudden they said, wait a minute, those radio amateurs are sending messages all over the world with a 15-watt transmitter. Why are we running this 200 kilowatt monster? Well, the answer to that is technology called the vacuum tube that allowed for much better receivers, and you no longer needed the huge amount of power for basically a numb receiver back from the teens. And also they need a lot more space for antennas. So they converted from very low frequencies, 44 kilocycles, to shortwave, today called high frequency, and they needed a lot more space for the transmitters, so they built Building 2 in Bolinas for the new shortwave transmitters. The receivers, they didn't have enough space in Marshall, so Dr. Harold Beveridge went up and down the coast, said right here, X on the map, build your receive site, and that is in Point Reyes along Sir Francis Highway. It had diversity antennas. There were 3 antenna fields, an A field to the west, a B field to the north, and a C field to the east for triple diversity reception. Because shortwave fades, doesn't fade in the same place. And the antennas were directional, so an antenna aimed at Australia would be mechanically planted in the ground aimed southeast, and an antenna aimed at Tokyo would be aimed nominally north-northwest. So they had antennas aimed at different directions times 3. So the whole field was full of antennas. And in 1931, RCA converted from very low frequency to shortwave. And this is a shot of RS from the air, and you can't quite see them, but the clear area was the antenna fields, A, B, and C fields. And this is the receive building at RS with some of the older antennas around it. This picture is probably 1960 vintage. And in 1941, a message was sent from Frank Geisel, urgent to all U.S. merchant ships, stop. Following from Commander-in-Chief Pacific, air raid on Pearl Harbor. Hostilities with Japan commenced with air raid on Pearl Harbor, stop. This is no drill. And that's the beginning of World War II. Again, the point-to-point service and the maritime service was taken over by the military for the duration of the war. As an aside, tomorrow is Fleet Week, and they'll do a parade of ships. Well, we will operate the radio room on the Jeremiah O'Brien with a couple members of the Maritime Radio Historical Society. So if you're on the Jeremiah O'Brien, you can go to the radio room, give them a message. They will send it via handset Morse code to KPH, and we will then forward the message from KPH, just like they did 50 years ago. Also, because we will send that message to the Jeremiah O'Brien, just because we can. Frank Geisel reactivated KPH at the Point Reyes receiving site at the end of the war in 1945. Station moved into the former point-to-point lunchroom on the first floor. KPH went in operation January 1st, 1946. So we had 2 different divisions of RCA in that building. Upstairs, the point-to-point service was RCA Global. Downstairs was KPH, RCA Marine. They were like brothers and sisters. They sniped at each other. The guys upstairs called the KPH guys the den of thieves. Of course, the guys at KPH said, there's a bunch of snobs upstairs. And that went on as long as the 2 operating people were at that building. This is the 2 operating positions in the front room at KPH. One of the maritime Morse operators at RS. And you can see where everybody had their licenses on the wall, because in those days you had to have your license on the wall, a nice little board with RCA and the call letters KPH. The wires strung there came off of the antenna field that were then patched into receivers. So this is a picture of a much later crew. And I'm going to kind of shift between radio history and talk about people, because RCA had the biggest payroll in West Marin for over 50 years. Between the KPH operators, the point-to-point operators, and the transmitter techs, they had a huge payroll. They made a major contribution to the economy of West Marin for a long time. So a couple of the characters out here in the back on the far left is the guy with kind of curly hair. That's Steve Bauer. Steve and I went to high school together. And because I knew Steve in the early 70s, I would go up to KPH when they were operating. Steve was the teletype operator, and we'd hang out in the teletype room, and I would watch it up and see what was going on and just hang out. So I actually was at KPH, was in full operation. So I do remember what it was like, which means that when I was recruited to get involved with this project, it was really easy because I'd already been there. I knew what it was. Okay. On the far right, the second from the front, is Bill Maloney. Bill Maloney was known as the nicest guy that ever worked at KPH. Bill was also known as the finest operator ever in the history of KPH. One of the stories about Bill was he was a Quaker. He did not have to serve during World War II, but he volunteered to be the radio officer on merchant ships in the Atlantic, was torpedoed twice, and just went back to work. That's the kind of people we honor by the MRHS. That's also why he came to work at KPH later, because you may not make as much money, but you don't have to swim. And in the center of the picture is Denise. Okay, Denise was the first woman operator at KPH, and she's a great lady, a member, one of the founding members of the Maritime Radio Historical Society. Denise grew up in Detroit, and if you know anything about the Midwest in the 70s, to call it depressed would be a compliment. And Denise realized she was never going to go to college. She didn't want to flip burgers the rest of her life, so she enlisted into the Coast Guard, became a radioman in the Coast Guard, was sent to station NMC, which is just east of KPH, of RS. She did her tour of duty in enlistment with the Coast Guard as a radioman, and when that came up, she came to work at KPH. She was the first woman to operate here at KPH. Well, a new guy traditionally gets harassed. A, she was used to it from the Coast Guard. B, she could dish out worse than I could. She learned how to do it in the Coast Guard. And ultimately, everybody got to love Denise. She's a wonderful person and a member of our group. The other thing about Denise was her Morse code was not machine perfect. She played with the rhythm between letters and words. It's called swing in the trade. And to the point where you could tell just from the sound of the Morse code, you could tell, oh, DA's on 12 megs tonight. Secondly, the other thing about Denise was a ship would call, you would go to the rack in the middle of the room there, which had all the messages saved for ships, look up the call sign, pull out the messages, sit down, send them the messages, they're waiting for them. You would take down any messages that they would have for you. At the end of that, the tradition is you would send 73 and your sign. 73 is Morse code, shorthand for best wishes. Denise was DA. But Denise did not send that. She sent 7388 DA. 73 is best wishes, 88 is hugs and kisses, and DA was her sign. So now there's a radio man somewhere in the Pacific saying, those guys at KPH are getting really weird. So the word got out that DA was a YL, which is shorthand for young lady. Now that there's a regular stream of radio officers who would come into San Francisco or Oakland, rent a car, drive up to Point Reyes with flowers and candy for Denise. She was that famous as being the DA from KPH. So that's some of the people stories of KPH, which I think is just as important and maybe more interesting than transmitters and receivers and wires and things. And there's a close-up of DA at position 1. This is the antenna field at RS. This is actually just the A field. So all the phone fields you see there are holding up directional antennas aimed in different directions depending on where they wanted to receive that. All those antennas are connected with 4-line feeds on what's called H-frames. So there's each group of wires there is one antenna being brought back to the building. And you're saying 4-wire. What's this 4-wire stuff? Well, if you're in audio these days, it's called star quad. And by doubling up the number of wires, you reduce the surface area, it has less pickup. So this is a close-up of what a 4-wire line looks like. And you notice that the 2 minus 2 and 3 are the minus polarity, and 1 and 4 are the plus polarity. And so by having two wires out of phase with each other, you reduce the pickup. And that was what RCA engineers did in the late 20s and the 30s in order to minimize pickup from the feed lines. So that's how far ahead they were of StarQuad. They were doing it a long time ago. The point-to-point receivers upstairs, these are the triple diversity receivers originally were there. They were DC powered. So on the first floor were batteries and motor generators to power them. So these were that, and if you can't quite see it in the picture, but there was a city or a location for each circuit. Each bank of receivers was connected to a dedicated antenna pointed at Australia or Japan or wherever. It was a point-to-receive site with the control monitors. 1963, those are newer receivers. Those are RCSSB R3s. Was one of the operators, Clarence Griffith. And then Steve is goofing off upstairs. He's supposed to be downstairs in the teletype room, and here he is hanging out upstairs with the guy at the control console and the point-to-point service. In order to power the first-generation receivers that ran on DC, they needed 6 volts at hundreds of amps, and they needed, I think, 180 volts. And so the motor generators made DC that then charged up the batteries, and then that went upstairs. You can see the huge bus bars in the corner there that went upstairs to power all the filaments of all the receivers. Okay, I'm going to move to my more favorite thing, which is called transmitters. Building Bolinas in 1913 was a challenge because there was no road into Bolinas in 1913. Everything had to be brought in by a ship to the dock in Bolinas and hauled overland by teamsters, a team of horses, that's why they're teamsters, out to the site. So here's building 1 under construction. Here's the building, and then you can kind of see a ring around that. There was a huge amount of ground wire that they used at that time. Overkill by today's standards, but that's what they have. One thing you're going to do, you notice there's kind of a ring around the building there. That was how they combined all the ground wires. One of the things we want to do is we're going to do an archaeological dig to determine what that ground ring looks like. But a Park Service archaeological dig will kill about 30 trees doing the paperwork to get permission to do an archaeological dig because it's the Park Service. This is building 1. The front part had controls and everything else, and the back part is where the actual transmitter was. Here's the antenna mast, one of the antennas under construction. See the lines in the ground? That was from the plow that plowed wires under the ground for the ground system. So those wires going underneath the antenna field as well as over the cliff into the ocean. They were one of the pressed steel towers that they used to hold everything up. Here's a shot of building 1 that's actually taken from the medium frequency tower much later. This is the rotary spark gap motor. This is the transmitter gallery. You see the motors driving the rotary spark gaps, transformers below, and the actual control panel on the little thing above that. There's a power panel, a close-up of that. When RCA took over, they replaced the spark gap transmitters with a mechanical way of making radio called Alexanderson alternators. Alexanderson was a genius engineer working for GE. He did a whole bunch of really great things for the electrical industry, and he figured out how to make an alternator that could make 44 kilocycles. And so and also figured out how to keep it on speed, which is keeping it on frequency. They had 2, main and a backup. And because these actually produced a continuous wave, they actually were much more efficient than a spark transmitter because a spark transmitter makes electrical noise. You filter out some of the RF and radiate that, but for these, they would make 200 kilowatts at 44 kilocycles, and that's what's connected to the antennas. There's a historic plaque that says that this was built by RCA, GE stuff, and everything else. The plaque used to be on building 1. We started there, it wasn't there anymore. But then we got a phone call saying, hey, you're the radio guys. And so we met someplace late at night in a dark alley. We got the plaque back. We're not going to put it on the buildings because some jerk will steal it, but we do have the original Alexander alternator plaque from building 1. This is one of my favorite pictures. These are the riggers at the base of the tower. There is probably a dozen OSHA violations in that picture. All right, no PPE, no hard hats, no this, no that. The guy is on a bosun's chair. Okay, the bosun's chair goes a pulley up, goes down behind the guys, and you can see a rope going off to the side, went to the bumper of a Model T. The way they raised and lowered people is they'd run the Model T back and forth, and that would move people up and down. It is totally unlawful today to do that, but these guys didn't have any problem. Best as we know, no one was ever seriously injured on the job. Now, there was a fair amount of cirrhosis of the liver because they drank like fish, and I'm pretty sure there's a lot of lung cancer and emphysema because they smoked unfiltered Camels, but these were manly men, and they didn't need all this foo-foo PPE that you have to have today. But anyway, there's a dozen riggers that worked at Bolinas and Point Reyes, keeping everything up. And there's building 2 and some of the antennas behind that, and you can see the Marconi mast above them. This is a shot looking from Mesa Road, looking west. You can see the Marconi mast. You can see a tower. That's the medium frequency tower, and a bunch of phone poles holding up stuff. One of the precious books we have is a book called Radio Antenna Engineering by Edmund Laporte, who's RCA's head engineer. In that book, there's a chapter on how you can splice phone poles to make them taller. Very practical information. And here's some of the fish spine curtain antennas that were used as directional antennas. It was RCA's kind of design that they used in the 30s. Here's the original shortwave transmitters in Building 2. Another shot of the transmitters in Building 2. And then business got to be so good, they needed to add more transmitters. So RC in the 50s built on Building 2A. And if you notice, Building 2A is an ugly concrete block building because corporate in the 50s looked for the cheapest way of keeping the transmitters dry. They weren't interested in a classic, good-looking building like Building 2. They just threw up a concrete block building with a tin roof and called it good. This is Building 42, which is the medium frequency tower and the guide AM tower. There's a couple of the transmitter engineers, Ian Nelson and Bill Maloney, in front of one of the Collins transmitters in Building 1. They weren't on the air in 1978. That was about when that was all getting scrapped out. And when the front of the RCA transmitter in Building 2, one of the operators in front of the World War II vintage BC 339 sets in Building 1. This is in the part that originally had the spark gap. And then Warren, who's was a transmitter maintenance guy, in front of BL10, which is a 40 kilowatt medium wave transmitter in Building 1. RCA had a contract to build these for the Coast Guard. They built 2 more. One is at BL and one at WCC. They're maritime coastal stations. The only one left, actually there's a couple of Coast Guard ones that have the transmitter, although it's not operational, and we have this, but unfortunately it's been raped. All of the meters are gone and all the copper's been stolen, so it's just basically the carcass of BL10. So here's Ivan in front of transmitter BL11, which is a 500 watt backup transmitter that was located in Building 42. So we started working up there, we found the table, and so, oh, that's a BL11 table, we got to save that. We did. And then we found some motor generators. Oh, that's the BL11 motor generators. We didn't have the transmitter. Then we were somewhere, and the lady in charge said, well, a lot of stuff in the basement. If it disappears, there will be no questions. 10 seconds later, that transmitter was on a handcart being loaded in the back of my van. So we now have BL11. One of our projects is to restore that and actually make it transmit. RCA in 1960 bought K and L sets. They were made by RCA Broadcast. This is one of the K sets. That was a 4-cabinet, 10 kilowatt amplitude modulated shortwave transmitter. And every transmitter in Bolinas had a label on it. This is transmitter 341H. It's an H set. But you notice it says 208R, that was a rhombic, aimed at 298 degrees towards Manila. So that transmitter is dedicated to a dedicated antenna aimed at Manila. And that's all it ever did was talk to Manila. So the H set was an RCA SSB T3, a 20 kilowatt independent sideband transmitter, very complicated transmitter. It made independent sidebands at like 100 kilocycles and was brought up to a couple more frequencies from the driver to the final amplifier, make 20 kilowatts. There's a wonderful group called California Coastline. They flew down the coast, took lots of pictures, and put it on the web. And you can go and look at that and see what the coastline looked like in the early 2000s. But then somebody in the States said, you know, we've got a closet full of slides. Do you want those? So they got the slides, georeferenced every single one, put them on their website. This is BL from the air in 1972. It's kind of a fuzzy picture because it's 35 millimeter, but you can see towers scattered around there. There were 40 transmitters in service in 1972. Each transmitter had its own antenna. So there was a lot of stuff. This is basically the south antenna field. The front is Building 1, and back among the trees is Building 2, Building 2A. This is the north field. You can see more towers, and if you look at it carefully, some more phone poles, and that was the north antenna field. And this is what put the point-to-point service out of business, was called satellite. And I'm calling that the beginning of the end. So gradually, the point-to-point service were cut over in the mid-'70s to satellite, and that operated from the second floor at RS until GE bought RCA and said, we don't need to run two of these. They moved all of the point-to-point, all of the satellite circuits from RS to the GE satellite place a few miles northeast of there. By 1973, all satellite links replaced all the HF circuits. And in 1977, RCA sold the property to the Trust for Public Land, which then resold it to the National Park Service in 1978. So now the land in RS and BL was owned by the Park Service. GE then said, we don't need this maritime stuff anymore, so they sold the license to KPH to MCI's Western Union International in May of 1988 and shut the station down. In the meantime, MCI invested over $2 million upgrading stuff at BL and RS, but technology moved on, and something called CyTOR, simplex teletype over radio is CyTOR. And all of a sudden, ships started using CyTOR, which did not require anybody involved. So a ship would send a message, would be received, and sent out over the network. Nobody was involved. So gradually, Morse code, hand-sent Morse code, declined and declined and declined and declined because the CyTOR message was a lot cheaper than hand-sent Morse code, and ship owners are cheap. CyTOR gradually took over manual Morse code, and one of the things that MCI did is they moved WCC, the East Coast Maritime Station, to RS and remote controlled it from RS. So we had two maritime stations working out of RS, but still declined and declined and declined. So MCI put KPH and WCC up for sale in 1995. The licenses were sold to Globe Wireless, KPH's primary competitor, and in June 29th, 1997, the last message was sent from RS and the transmitter BL were turned off. And this is the last message sent from KPH. CQ, which is calling all stations, DE from KPH. From all the staff at Bolinas Radio KPH to our colleagues ashore and at sea, this announcement marks the end of broadcasting from our location at Bolinas and Point Reyes after 85 years of service. To the maritime community, we wish you fair winds and following seas. 7388 DEKPH SK. So SK is shorthand for silent key. That's when you don't transmit anymore. And then also, KFS went out of business in 1999 when you were no longer required to have a radio officer on board the Merchant Marine. So the last message sent was, "What hath God wrought?" Again, SK. So the National Park Service, Point Reyes National Seashore, inherited a fully functional radio station after the license was sold. And the Maritime Radio Historical Society, the founders, said, we can't let this stop. And so they went to the Park Service and said, we will operate, maintain, and interpret this station for you in partnership with the Park Service. And believe it or not, the Park Service said, okay, and now we partner with the Park Service to maintain, operate, and interpret the station. What I'm doing now is called interpretation. So this show list says Park Service, this show list is MRHS. And that's how we can do that now. WCC doesn't exist. It was bulldozed. It's now open space. The WCC receive site is a museum, but they can't operate. They have a transmitter there, but it's just fake to look like it's operating. They don't do anything. All the antenna field's gone. They were able to get Walter Cronkite to narrate a video for them, but they can't operate. We can actually operate. So now, let's look about some of the archaeology that we do at the site, trying to figure out what happened over 100 years of operation. A lot of stuff in the field. This is a Marconi mast guy anchor. So that lump of concrete is around every mast that existed once. This is the base of a Marconi mast. They just cut it off and scrap the steel. This is a base of the Alexanderson tuning helixes. One of the things Alexanderson did is he redid the antenna system to make it more efficient with multiple tuning units. And so in the middle, you see these helix bases. On top of that was stacked a big coil of wire. And with Google Earth, we can see all kinds of stuff. You can see a dot with 4 dots around that. That is what was the Marconi mast and the guy anchors. You can also see another one closer to the building and some other little ones scattered out there. This is the tuning base and feed point anchor next to building 1. The wires came off attached to that. This is another shot looking the other way. There's building 1 behind that, and then that's the anchors there. This is a shot from California coastline showing some of the antennas, the medium frequency antenna, building 2 and building 1. This one you can see some of the foundations for some of the towers, antenna-based towers. They're all over there. There's 4 of them together that held up a tower. Another shot of tower anchors. And you can see carefully on Google Earth some of those tower bases. This is from California coastline. That's what used to be there. That was a bunch of towers holding up an antenna. Could be a rhombic. When they cut down all the trees, what are you going to do with the old telephone poles? So there is what we call the elephant graveyard in the field, and there's a bunch of rotting old telephone poles. The one in front is actually spliced. They took a 90-foot pole, spliced it to another 90-foot pole, and make it a taller phone pole. You can't get much more than a 90-foot pole. This is an H-frame that supported the 2-wire transmission lines. So let's look at what we have today. This is the control room for building 2A. The supervisor was on duty there. He monitored everything. And if there was a problem, he'd get on the intercom and say to the on-call tech, hey, transmitter 28 has an overload. Go take a look at it. These are the tone sets. The rack on the left had tone sets that came from San Francisco. RCA had private telephone lines, 6 pairs of private lines coming from San Francisco across the Golden Gate, and then their own wire up into Bolinas. And the middle rack is what we use now to control the transmitters from RS. So the keying in RS does audio frequency tones that come out of these sets, turn into keying that keys the transmitters. Here's the transmitter gallery. The brown transmitters are RCA transmitters from the 60s. The white transmitter behind there are Henry 5 kilowatt high frequency transmitters. Those are the feed lines leaving there. We run balanced lines, open wire lines to feed all of our antennas. The medium frequency tower rusted out, so it was replaced with a Marconi T antenna. This is the support pole at building 42, and the wire goes back and forth from that. Building 1 behind the helix base, the front of building 2 today. You notice the difference between building 2 and building 2A. This was a classic looking building. This is transmitter supervisor Steve Hawes looking at RCA transmitter. And we do hands-on work on our transmitters. There's Steve deep inside one of the K sets. And it's Tom Horsfall at a K transmitter, which is on the air. This is one of our historic transmitters. It's called the PW15. It was built by Press Wireless. They built transmitters for their own system. Press Wireless was an international service for press. So if you're a correspondent somewhere in the world and you need to send a message back to newspaper, you'd find the local press wireless office. They would then send that message to your newspaper. Or if you're a newspaper anywhere in the world, you could subscribe to a service in press wireless, and over shortwave, they would send world news to you, and you would have a Morse operator there copying it down. That's how you got there. So when this particular transmitter was made for the United States Army during World War II, I think 1942, it was at the press wireless transmitter site in Belmont. When that was shut down, the transmitter moved to KFS in Palo Alto, and then when that was shut down, they gave us 2 of the transmitters, and we hauled them up, and one of them is fully restored and on the air every Saturday. The other one just needs a few hundred hours of restoration to put it back together and make it work. The H-set restoration is another interesting story. We do get people want to come by and take a look at us. A group of engineers from Santa Rosa came by and said, "Oh, this is really cool." They came back later and said, "What can we do to help? We want to get involved. What are you going to do?" So we looked around and said, "There," and pointed to an H-set and said, "Make it work." And they looked at it and said, "You're crazy." "Yes, we know that." "Are you sure?" "Yes, we're sure." "Okay." So this is what the inside of an H-set looks like when it rusts out or corrodes out. This is the driver's stage with a couple 4CX250s. It's so corroded that the sockets are broken and other parts are broken. So they took it apart, completely apart, removed strip screws and everything else. This is the output tuning network that they removed. Here it is after they cleaned it up. They knew how to turn corroded silver into fancy silver and flipped it all up. It was just beautiful. And there's another shot of a tuning coil. We had to replace a lot of mica capacitors that blew up. And here is the final amplifier being rebuilt. The plate that everything is mounted on was so corroded, they took accurate dimensions and had a metal shop build a new plate for it because they decided it wasn't worth trying to redo that. So 3,000 hours of volunteer labor. We had an operating RCA SSB known as an H-set, and their superintendent, Cicely Muldoon, she's turning it on for the first time for regular service. And we had all of the VIPs and the brass from Point Reyes National Seashore there watching this being turned on. And then here is it lit up status, and then the big red light saying plate on. And there's amps going into the antenna. So this is the message we sent when we turned on the H-set. CQ, 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 DE, KPH, KPH, KPH. Please stand by for a special message. This is the first official transmission from RCA T3 transmitter number 298 since it was abandoned and left for dead years ago. Now its voice is heard once again from the RCA transmitter site in Bolinas, California. We believe this is the only working transmitter of this type in the world. The restoration of this transmitter was carried out over 3 years by a dedicated team of Maritime Radio Historical Society volunteers, all current and former Hewlett-Packard engineers. That's why they did a good job. Transmitter 298, once a corroded hulk, is now a sleek and powerful example of the best in industrial design. Like all transmitters at the Bolinas site, the transmitter 298 is the property of the Point Reyes National Seashore, part of the National Park Service. Thus, in a sense, it belongs to all Americans. Point Reyes National Seashore Superintendent Cicely Muldoon did us the honor of pressing the button to bring transmitter 298 back to life today. None of this would not have been possible without the vision and trust of the men and women at Point Reyes National Seashore. Listen to this transmitter 298 on this frequency later today at 1701 PDT 0001 Zulu when Night of Nights 2013 officially begins. We wish you fair winds, following seas, and good listening. So that is a wonderful example of really hard work. Now, we did enter that transmitter into CHRS restoration contest, and it was completely blew the examiners away. They didn't know what to do with us. They were used to little radios like this one or one of the radios you see here. We couldn't bring the transmitter, then we had full documentation, and their heads exploded. They didn't know how to deal with that. But anyway, and that's the main nameplate for that transmitter. This is regular operations. Position 1 controls is the supervisory control for everybody. There's Chief Operator Richard Dillman. Position 1, we have 2 control panels. The blue panel is KPH. The black one is WCC, which we now use for K6 KPH. Tone sets at the bottom of the rack there connect RS to Bolinas. Our biggest problem is antenna maintenance. We can fix every transmitter. We can fix every receiver. The electronics are easy. The problem is that antennas are in a marine environment and they're corroding because they're next to the ocean. I mean, that is a basic thing. Rust never sleeps. So we're having problems. The APS, National Park Service, does not allow volunteers to climb. Even if I could, I used to, but I don't do it now, we're not able to, so we must retain a contractor, which ends up being lots and lots of dollars. Our main problem, both at Point Reyes and in Bolinas, is failing guy anchors. There are screw anchors that are screwed into the ground. They were galvanized steel, but the galvanized goes away. We have what's called pencil point failure, where it corrodes and corrodes and corrodes. It becomes such a tiny bit of steel. In a windstorm, it breaks, snaps off, and a guy snaps over, and the pole is on the ground. If one anchor fails, we will actually screw a new anchor into the ground and retension it. If we lose 2 guy wires, the pole comes down because nothing is holding it up. And 2, we need heavy contractor resources. So this is an example of one of the major projects we just completed with the Marconi T antenna at RS. This is the south support pole of the Marconi T, and you can see it's buried in a pine tree. There shouldn't be trees out there, but they planted them, and then the squirrels are really good about replanting them, so we end up with a lot of trees out there. And what happened is one of the branches broke off of the pine tree, landed on a guy wire, ripped off the belly band, and so the guy was loose, and so the antenna got pulled over. So we hired Park Service finally came up with $100,000. We hired a contractor that eliminated trees and a whole bunch of other work before you even got to work on it. He completely new anchors and re-guide the pole. Bought all new wire. This is the Marconi T horizontal wire and the vertical drop down that had it all put together. And this is the feed pole. There's a wire coming down to an insulator, loops down to the feed, the tuning box, and then coax back into the building. So we operate, okay? This is not a static display. We're actually on the air every Saturday. We have special events, Night of Nights, and International Marconi Day. July 12th, 1999 was the last day of commercial Morse code. On July 13th, no radio officer was required in the Merchant Marine. And as I say, thumbing its nose at convention, we have a special event every year, Night of Nights, starting at 0001 Zulu on July 13th, the day after there was the end of Morse code. With every transmit antenna that we have, on KPH, KFS, and KSM maritime frequencies, basically telling the world we're still there and extending our index finger at the world. So the people that said there's no more Morse code, guess what? We're still on the air. So there's Chief Operator Dillon getting ready to do that. And this is a long time ago. Ray Smith, who was watching, senior operator from KPH, he's passed away. Dillon getting ready to send. We operate a couple positions on amateur frequencies. There's position 6, and there's a Roy. And then at the end of the night, we send a special blessing from Bolinas, and this is Denise sending the blessing message, and again, hand-sent Morse code. The thing about Denise is most of the time she's using a bug, and it's just a little back and forth motion. Denise uses fully body English, and she has got about a dozen bracelets on her arm. So while she's doing that, she's doing this and up and down and making a lot of noise with all of her bracelets, sending a message. There's a video of Denise on YouTube. International Marconi Day is a worldwide celebration of Marconi, and a few times we've actually remote controlled the station from the Marconi Conference Center. So for Marconi Day, we're on the air from original Marconi locations, Marshall and Bolinas. No one else in the world can do that. But we were on the air from that, open to the public. And it had a huge amount of people wandering by. So we had to set up 2 operating positions. We hauled literally a ton of boat anchor receivers and other equipment, strung antennas, and made it operating. So here's Jack Martini and Ray Smith, former operators of KPH. They're both passed away now, operating the stations. They couldn't wait to get there. They had so much fun that day. And then this is the RS building at night for Straight Key Night in 2011. So, no matter what, we have to deal with the FCC. Because the KPH frequencies had been moved away from Bolinas, we applied and were licensed by the FCC for KSM at Bolinas for the transmitters we have there. And so we can operate on maritime frequencies legally with the call sign KSM, but we've also arranged with Global HFNet LLC to move KPH frequencies back to Bolinas. So actually now the original KPH frequencies are licensed at Bolinas, and we have an agreement with Global HFNet to operate those transmitters. So we're actually on the air with original KPH transmitters, original KPH frequencies. We accept traffic from ships at sea, and we'll forward messages, but we don't charge for it. These are the frequencies we operate. Medium frequency, 500 calling, 426 kilocycles, our operating frequency, and then 4, 6, 8, 12, 17, and 22 megacycles. Those are standard international ship frequencies. And then we also operate a teletype on those three frequencies, although not now because we've got too many antennas on the ground. We're on the air every Saturday. We welcome the public for a tour at RS. Basically, it's called the tree tunnel. We call it the driveway. An interesting side story. Legend has it that somewhere in the 30s, a bigwig from RCA, could be Sarnoff, we don't know, came and visited the site and said, that driveway is boring because the terrain there is coastal scrub, little bushes and grass, that's it. So when the bigwig says do something, they bought trees in 1-gallon cans, little trees, planted them and hand watered them for a few years until they were established. 90 years later, it's now called the tree tunnel, and people come to look at the trees. I remind people that I would not be standing there during a windstorm because the branches this big fall off, which they do. It really hurt. But anyway, that's the tree tunnel officer, Francis Drake. We operate on amateur frequencies, and we don't rag chew. We are very terse, and we use standard commercial Morse code procedures to do that. We do special broadcasts for ARRL, such as code practice runs and field day bulletins. And if you're a Morse qualified person, you can come out and operate our station. So even though we're living firmly in the past with handset Morse code, we do have a pretty good website with lots of pictures and information about the station and assorted stories and everything else. radiomarine.org is our website. So, any questions on my blather here? Monsieur Verdier.
When I was there the last time, all the rectifiers were going in sync with the code.
Yes.
Is that code originated at Bolinas, or is it originated elsewhere?
If it was early in the morning that was coming off a computer in Bolinas, during the day it's operated from RS. With the PW15 transmitter has the original mercury vapor rectifiers, which is a problem because mercury is hazardous material and blah, 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 blah. But we have enough of them, we operate that. And so when it's not keyed and not drawing any current, there's a faint blue glow. But when you actually key the transmitter drawing current, the blue glow gets fairly bright. And so whenever visitors come by, they always want to get their eye thing out and make a movie of the lights flashing. Okay, great. Knock yourself out. But anyway, if you're in operation 24 hours a day, 7 days a week, A, you would not be using a vacuum tube transmitter, and B, you certainly wouldn't be using mercury vapor rectifiers. You can't buy them anymore. We have hundreds, so we actually have a mercury vapor tube tester so we can make sure we have good ones, because we have a lot of bad ones. We make sure we have good ones, we test them, and that's what we use on the PW15. Any other questions? Okay.
Are you looking for more volunteers?
And if you're interested in the history of radio, we're always looking for volunteers. So tell all your friends, we're looking for volunteers. I mean, you have to work in Point Reyes. I mean, that's the hard part. But other than that, it's just a matter of getting involved with us, and we will definitely bait the hook and reel you in. So, any other questions? Mansoor?
Yeah, another question.
Huh?
Okay, a dozen questions, but I'll make it one question.
Yeah.
Have the radios gotten better over years so they can transmit and receive from the same physical location?
No. No, and if
The descents issue,
at VHF and above, it's easy to do. But at high frequency, in order to get a couple wavelengths of separation at 4 megacycles, that's a lot of separation. So it's very common.
desenses the receiver.
Yeah. It's very common to operate full duplex in commercial high frequency service, whether it's maritime or point-to-point or anything else. And it also allows you, while you're sending a message, to monitor the calling frequency in case somebody calls with another message. So it's how it's done.
It's not a selectivity issue. It is the nature of the beast.
You can't have a receiver with a microvolt sensitivity with 1,000 volts coming down the antenna.
Yeah.
You know, one of the interesting things that I didn't mention, but okay, we're living in the past. The station go back to 1905, blah, blah, blah. But if you go to our website, radiomarine.org, there's a button you can click on for software-defined receivers that exist at Point Reyes. And so the SDRs there are connected to the antennas we have. And the problem is that the receivers are so sensitive that broadcast stations are overloading them. And so actually tomorrow I'm going to be working with Rob and improving the dynamic range of the SDRs. But so yes, we have old receivers and everything else, but you can go online and use the Kiwi SDRs that we have anywhere in the world. One of the other interesting things we do, and it's coming up, a volunteer organization is not like being in the military. Okay, you have to work around everybody, but we actually broadcast encrypted messages. Okay, the know nothings in the amateur will go, oh no, you can't do that. No, that's not true. Amateurs are not allowed to send an encrypted message. However, in the maritime service, not only can you, it was traditional that if a ship wanted to send something to the owner and didn't want everybody to hear it, they would encrypt the message. So we twice a year, we will send an encrypted message. The last one was a one-time pad, Cold War era kind of thing. Probably the one we'll be doing in another month or two will be an Enigma encrypted message. And last time we had like 150 people all over the world monitoring us and sending in the decrypted message to get a certificate from us. So that's another thing we do for fun is encryption. So it's because we can. Yeah. So any other questions?
Do you have an Enigma machine?
No.
Would you like to?
We don't have $100,000.
No, I don't mean it like that.
Oh. You have one in your collection?
I don't have a collection, but I certainly know somebody who does.
Okay. We would be happy to have one. We know several people that are, Ralph Shanks, who has an encryption museum down in San Jose, doesn't have one because he can't afford one. The Germans had tens of thousands of these machines, but after World War II, most of them were destroyed by the American government. So there's only a handful left in the world.
I know where 21 of them are.
Okay. There is a computer program that very accurately does the same thing in software, and there is a kit you can buy that will reproduce it. But the real honest Enigma is literally $100,000. Or more, yeah. I didn't win the lottery, so that's a problem. But if you can promote one, Steve, we'll make sure you get a certificate of appreciation.
I will call the appropriate number.
Oh, okay. Yeah, this is all part of trying to do that. And one of the things that is great because of these guys, okay, we think of the Park Service as Yosemite, okay? Beautiful trees and that kind of stuff. The Park Service main mission is history. The East Coast is full of little history things that had to do with the history of the United States and everything else. And so having a historical radio station is within the park's purview. And because this is the only operating station, maritime coastal station in the United States, it's a big feather. Cecil Muldoon was totally behind us and really did great stuff for us. Unfortunately, she got promoted to this place called Yosemite. Yeah. So we just got a new superintendent, but the last two superintendents have been also totally involved with us, and all of the staff in Point Reyes National Seashore supports what we do. And other than the fact that the Park Service does not get funding from the Congress, they're underfunded nationwide. So every year the superintendent puts in a list of things for us, and every year those get crossed off. So that is a problem with the Park Service. So if you want to do us a favor, please tell your elected officials to fully fund the Park Service. I really shouldn't say fully fund Point Reyes National Seashore. I could get in trouble for that. But I can say, please fully fund the Park Service, because that will help everybody in the United States. So that's my little pitch there.
You do accept donations also.
What?
You might want to remind people you do accept donations.
Oh, yeah, yes, our website does have a donate now button. When we did the last crypto event, we included a, please donate. And we got like $1,500 of donations from people, and all in small amounts, but it all adds up, And I know that Rochelle has a similar problem keeping this place lit and running. And if you haven't donated to restoring the front, it needs it. I mean, the best thing that ever happened to this building is tearing off that ugly facade and restoring that. So enough of that.
When's your Enigma day? When's the Enigma message?
Be probably December.
Oh, that's a nice month.
Yeah.
Bill, why don't you just conclude? That's my presentation. Thank you. Appreciate being invited to CHRS. If you could just say that, I want to put that in.
Okay. You're a good editor. Anyway, thank you very much for listening to me talk about Maritime radio station KPH. And I wish all of you fair winds and following seas.
Hear, hear.
Thank you so much, Bill. Thank you for attending tonight. And just as they accept donations, so do we. Safe travels home. Thank you.